Additive manufacturing, myself Dr. Suman Das, Professor, Department of Mechanical Engineering, Swami Vivekananda Institute of Science and Technology, Kolkata. Additive manufacturing, the code is PEME802F. Now the question comes, why laser is used in AM process? The laser, that is the full form is light amplification of stimulated emission of radiation, provide a high intensity and highly collimated beam of energy that can be moved very quickly in a controlled manner with the use of directional mirrors. So in this diagram, so there is a yellow color, the machine, from that laser machine, from that the red color laser beam is coming, and there are two directional mirrors are used. So ultimately the laser is entering through the focus lens and to the workpiece. Additive manufacturing requires the material in each layer to be solidified or joined in a selective manner. Lasers are ideal for use provided the laser energy is compatible with the material transformation mechanism. There are two kinds of laser processing used in AM process. Number one is the cutting and number two is heating. In the case of heating, the requirement is for the laser to carry sufficient thermal energy to cut through a layer of solid material to cause powder to melt. That means that thermal energy is used for melting the powder, or to cause sheet of a material to fuse, or in the case of sheet, if we use the sheet, in the case of that, heat is used for melting the sheet. Secondly, to melt the material in a controlled fusion without creating too great a build up of heat, so that when the laser energy is removed, the molten material rapidly solidifies again. So in this case, not too amount of build up heat is created or generated. For laser cutting, the intention is to separate a region of material from the another. So this is the laser cutting intention, to separate the material from the one from the another. So number of classification of liquid polymer system, discrete particle system, and molten material system, and solid sheet system. Liquid polymer system. So the stereolithography apparatus, that is the short form is SLA, stereolithography apparatus process. Now we will discuss that SLA process. Liquid based RP system, that means rapid prototype system, have the initial form of its material in liquid state. The liquid is converted into, after that the liquid is converted into solid state. The first commercial system was 3D system stereolithography process based on liquid photopolymers. That means liquid converted into solid. This 3D system was founded in the year of 1986 by inventor Charles W. Hall and the entrepreneur Raymond S. Fred, and its first commercial system marketed in 1988. The SLA, stereolithography apparatus process, is based on the following principles. parts are built from a photocurable liquid resin that cures when exposed to a laser beam, that is photopolymerization process, which scan across the surfaces of the resin. Now, what is photopolymerization process? A photopolymer, what is photopolymerization? A photopolymer or light activated resin is a polymer that changes its properties when exposed to light. That means that photopolymer, when exposed open to the light, so its properties will be changed, often in the ultraviolet or visible region of the electromagnetic spectrum. Now, photopolymerization is a technique that uses light, visible or ultraviolet. The light may be visible light or the light may be ultraviolet, to initiate and propagate a polymerization reaction to form a linear or cross-linked polymer structure. So, if you see the diagram that is in the right hand bottom side, so first box, that is the liquid polymer, that means before exposed to the light. So after exposing to the light, that means UV light or the visible light passing through that liquid polymer, and the liquid polymer, so that induced polymerization by light, that means creating different chains. So that is called the photopolymerization. The result of photocuring is the formation of a thermoset network of polymers. So that is the thermoset polymers. The building is done layer by layer, each layer being scanned by the optical scanning system and controlled by an elevation mechanism which lowers at the com competition of each layer, completion of each layer. Now, if you see the diagram, so the diagram indicating that the yellow color, that is the laser source, and XY scanning mirror. So this is the deflected mirror, and this is the resin tank. After that, the UV curable resin, and that is the cured layers and movable build platform. So the platform is moving from top to bottom, gradually moves downward. So this is the in the right hand side, that is the elevator. Now the component. Every standard SLA, that is stereolithography 3D printer, is generally composed of 4 primary sections. That means there are 4 primary sections of every SLA 3D printing device. Number 1, a tank filled with liquid photopolymer. The liquid resin is usually a clear and liquid plastic. First one is a tank, and inside the tank there is a liquid polymer. Number 2, a perforated platform immersed in a tank. So there is a platform, that platform will be immersed inside the photopolymer tank. The platform is lowered into the tank and can move up and down according to the printing process. That means the platform can be moved ups and downs as per the requirement, as per the printing process. Number 3, a high powered ultraviolet laser is used for this process. And finally, a computer interface which manages both the platform and the laser movement. So these are the components used in SLA stereolithography 3D printing system or process. Now the question comes, next we will discuss how does it work. This is the there are the 6 diagrams. First one is the data or 3D CAD. First of all, we have to produce a 3D CAD data. After that the 3D CAD model will be converted into 3D data to STL format data, and after that STL file will be entering into the stereolithography, and after that if you follow the arrow, that is the that will enter into the platform, and this is the platform hardening the first layer. So the first layer, so after solidification of the first layer, so the entire the system will be lowering down, and finally the hardening the final layer, and if you see the layer will be formed, and after forming one layer by another layer, another layer by another layer, so entire product will be produced. Now the software. First step, the first step consists of designing a 3D model through CAD software. Secondly, the resulting CAD files are digitalized representation of the desired object. The CAD file must be converted into STL file, and that is the standard triangulated language. So that STL file describes the surface geometry of the 3D object, and to feed that STL file into the 3D slicer software such as CUDA, such platforms are responsible for generating G code, the native language of 3D printers. Now, SLA 3D printing. Now we will describe the SLA 3D printing. When the process starts, the laser draws the first layer of the print into the photosensitive resin. Whenever the laser hits, the liquid solidifies. So the laser is coming first, and that laser when hits the resin, that resin will solidify first. Next, the laser is directed to the appropriate coordinates by the computer control mirror. So there are computer control mirror, so that laser is entering into as per the direction. SLA printers work upside down. The laser is pointed off to the build platform, which starts low and it's incrementally raised. After the first layer, the platform is raised according to the layer thickness, typically about 0.1 mm. That means the thickness of the layer should be 0.1 mm, and the additional resin is allowed to flow below the already printed portion. The laser then solidifies the next cross section, and the process is repeated until the whole part is complete. So this is the process. Until the whole part is completed, the entire system will be repeated. The resin that is not touched by the laser remains in the vat and can be reused. So this is the another advantage of STL process, SLA process. So the unused resin can again be reused. Now there is a very important thing that is called the post processing. After finishing the material polymerization, the platform raise out of the tank and the excess resin is drained. That means excess resin may be drained from that platform. At the end of the process, the model is removed from the platform, washed of excess resin, and then placed in a UV oven, ultraviolet oven, for final curing. That means after removing the object from that platform, so that will be washed and resin will be, excess resin will be removed, and finally that model will be placed in the UV oven for final curing. Now post print curing enables object to reach the highest possible strength and become more stable. So some painting on that product is required, so that post print curing enable objects to reach the highest possible strength, so that will increase the strength of that object when that is coming out from the UV oven chamber. Now the application: models for conceptualization, packaging and presentation, prototypes of design, analysis, verification and functional testing, parts for prototype tooling and low volume production tooling, patterns for investment casting, sand casting and molding. So these are the wide range of application of this process. Thank you.